Pipelines are a means of getting data from one place to another effectively. They're commonly used by engineers across the world for this purpose. There's four main stages of a data pipeline: ingestion, storage, processing, and visualization. We're going to look at all of these very soon in this course. In this lecture, we're going to talk about ingestion, processing, and visualization. We're going to talk about storage later because there's a lot to talk about there. Cloud SQL is a fully managed relational database for MySQL, PostgreSQL, and SQL Server. Cloud Spanner is a fully managed relational database service that scales horizontally, is strongly consistent, and speaks SQL. It offers 99.999% availability with automatic software updates and instant optimizations. You get zero downtime and no maintenance window. It's used to power workloads, large and small, for applications for just a few to massive apps with global users. BigQuery is a huge part of Google Big Data suite of products. It's really important to understand this on the fundamental level. On the highest level, the way to understand BigQuery is that it is a data warehouse that is operating on a petabyte scale. BigQuery is highly scalable on short notice and is serverless in architecture. BigQuery has what is known as an in-memory business intelligence engine, or a BI engine as we would call it for short. This is an amazing tool for quickly creating interactive reports and dashboards. One of the main reasons and use cases that you will see people using BigQuery is for its machine learning capabilities. BigQuery is a great tool for you to build your machine learning models in via SQL. Lastly, BigQuery provides support for geospatial storage and processing of data. Cloud Bigtable is Google's fully managed NoSQL big data database service. It's the same database that powers many core Google services, including Search, Analytics, Maps, and Gmail. It is optimized for high read and write throughput at low latency, and it's an ideal data source for MapReduce operations. It also has performance at scale, which means it has a highly scalable database. Memory Store reduces latency with scalable, secure, and highly available in-memory service for Redis and Memcached. Choose from the two most popular open source caching engines to build your applications. Also choose the right engine that fits your cost and availability requirements. Datastore is a highly scalable NoSQL database for your web and mobile applications. Datastore automatically handles sharding and replication, providing you with a highly available and durable database. Dataproc Introduction. Before this point, you've understood what Hadoop and Apache Spark are, and what Hadoop jobs and Apache Spark jobs are. Dataproc exists to make the lives easier for both these systems. Dataproc is a managed cluster service within GCP that is used for running Spark and Hadoop jobs. It takes away the major management elements of handling clusters, VMs, and storage by yourself and takes those tasks upon itself so you can worry about the jobs themselves. Dataproc will set up the managed service, and all you'll have to do beyond that point is send jobs to it. The real question that a lot of people have about Dataproc is why should they even use it? Wouldn't it save you money to just do all the management of the clusters, VMs, and storage by yourself? Yes, it's true. If you decided to manage things yourself, you would save a bit of money. However, you need to understand that setting up Hadoop and Spark clusters is a lot of hassle. First, you have to set the VM up, and then you have to allocate the storage, the processing, and memory. Then you've got to install the software on the VM. And then you've got to repeat this process a couple of times to make the cluster. At this point, you might be thinking that this is a one-time thing that you can get over with easily and just move on. Not so fast. Down the line, you're going to need to grow your cluster. That's going to entail repeating the entire process again until you've gotten the growth you want out of your cluster. You also need to consider the downtime on your cluster. You won't always need it working for you, but just having it up and running is going to incur cost for what is essentially just wasted extra resources. This is also a good means of understanding why, generally speaking, managed services in the cloud are the better choice. Let's understand what's inside Dataproc and how it works on the inside. On the top of the hierarchy is going to be your master node.
This node is going to be running the Yarn Resource Manager and HDFS named nodes. Then below that, you're going to find the worker nodes. These worker nodes are going to be running the Yarn Node Manager and will be HDFS data nodes. Each node will automatically come pre-installed with the latest stable build of Hadoop and Spark already on it. Not just that, but it's going to have a lot of other tools like Zookeeper, Pig, Tez, Jupyter Notebook, Hive, and a GCS connector. Beyond these, there's also many more components that you can install and add to your nodes. You can even create a custom image to be deployed to your VMs within Dataproc if you so desired. All the lower level management of storage and clusters is handled by the Dataproc service. Here's the major benefits of working with Dataproc. The first one is speed and the way in which you're charged. To set up a cluster that's ready to go takes about 90 seconds. Then, once the resources are up and running, you're charged per second with a minimum billable of 1 minute. This means that you can set up shop and process datasets, or even scale up or down an existing cluster. You can even turn it off entirely if required, and pay only for what you've used. The way Dataproc is used is as follows. You can submit the Hadoop or Spark jobs, the same way you would for any service associated with Hadoop or Spark. Dataproc is compatible and interoperable with both of these. If it's required, the cluster can be set up such that it auto-scales according to the job load it receives. The outputs you receive from Dataproc can very easily be pushed to GCP services like Cloud Storage, BigQuery, and Bigtable. Dataproc integrates with Stackdriver, and you can use it for logging and monitoring job performance and output. Introduction to Dataflow. Data is generated in real time from different sources, but capturing, processing, and analyzing it is not easy because it's usually not in the desired format for your downstream systems, and the solution to that is Dataflow. Dataflow is a fully managed streaming analytics service that minimizes latency, processing time, and cost through autoscaling and batch processing. Dataflow is about streamlining all the data that is collected from various sources and compiling it at one place, then effectively processing it to find suitable solutions. The Apache Beam SDK is open source and is used by Cloud Dataflow. You may quickly define data processing pipelines using the Beam concept. The parallel task execution method effectively processes the pipelines that you define. It removes operational overhead from your data engineering teams by automating the in-structure provisioning and cluster management. You may be wondering at this point how Dataflow works. Dataflow works in a very simple method. You read the data from the source, transform it, and write it back into a sink. Typically, the data we wish to process will begin in a data source. The processed data must be added to the data sink. We establish a pipeline that will handle data from the source before sending it to the sink. You can read data into your pipeline and then post your output data into the sink using Apache Beam connectors. BigQuery, Cloud Storage, and Cloud PubSub are a few popular data sources. BigQuery, Bigtable, and Cloud Storage are frequently used data sync methods. Data synchronization can be done via cloud machine learning. The pipeline is specified by the driver software. P collections are utilized in the pipelines and serve to represent the data as it is altered. A multi-element, potentially distributed data set is represented by a P collection. Both batch and streaming data can be represented with P collections. The data set is bounded and is handled as a batch when it originates from a fixed source, such as a file. The data is described as being unbounded and is treated as a stream when it originates from a continually changing source, such as a smart device emitting events. Although the initial P collection can also be built from in-memory data, pipelines commonly constructed by reading data from an external data source. A transform denotes a stage in your pipeline or a data processing procedure. Use P collections as inputs and outputs for your transformations. Your pipeline will be defined by several transformed phases, each of which accepts one or more P collections as input and produces 0 or more P collections as output. It provides portability with the processing pipeline created using open source Apache Beam libraries in the language of your choice, either Python or Java, and applying it as a Dataflow job. Dataflow then assigns the worker virtual machines to execute the data processing. You can create Dataflow jobs using the gcloud command, Google Cloud's online interface, or the API. When it comes to using Dataflow, you can use pre-built or custom templates, SQL statements, or AI platform notebooks. Dataflow has two data pipeline types, streaming and batch. Both types of pipelines run jobs that are defined in Dataflow templates. A streaming data pipeline runs a Dataflow streaming job immediately after it is created. A batch data pipeline runs a Dataflow job on a user-defined schedule. The batch pipeline input file name can be parameterized to allow for incremental batch pipeline processing.
You can store, manage, and secure container images and language packages with Artifacts Registry and Docker images with Container Registry. Cloud SDK is a command line interface to script and manage Google Cloud products from your own computer. Cloud Code allows you to extend your IDE tools to write, debug, and deploy Kubernetes applications. Cloud Build allows you to continuously build, test, and deploy containers, Java archives, and more using Google Cloud infrastructure. Cloud Scheduler lets you schedule batch jobs, big data jobs, and cloud infrastructure operations using a fully managed cron job service. Asynchronously execute, dispatch, and deliver distributed tasks with Cloud Tasks, and manage workflow and extend Git workflow by connecting to Cloud Build, App Engine, Cloud Logging, Cloud Monitoring, PubSub, and more. Multi-cloud is a strategy that leverages two or more cloud services. It also refers to the use of multiple private clouds and public clouds. Hybrid cloud refers to a mixed computing, storage, and services environment made up of on-premises infrastructure, private cloud services, and a public cloud. A hybrid cloud becomes multi-cloud when there are more than one public cloud services combined with a private cloud resource. Let's discuss some hybrid multi-cloud services for Google Cloud. Anthos is Google Cloud's new managed application platform that enables you to run Kubernetes across on-premises, as well as on multiple public clouds, with a Google Cloud-backed control plane for stable operations. It is used to modernize existing applications and building new applications rapidly while enabling consistency between various environments. Google Cloud VMware Engine offers flexible on-demand capacity and full operational consistency with existing on-premises environments. Anthos clusters on VMware provide a way for you to create Google Kubernetes engines or GKE clusters in a vSphere environment on your own premises. With GKE on-prem, you can run your Kubernetes cluster in your data center from the Google Cloud Console, allowing you to take advantage of managed GKE and to make handling and monitoring easier. You can automate policy and security at scale for your hybrid Kubernetes deployments. You can easily leverage the benefits of combining Kubernetes and serverless with Cloud Run. You can use Apigee in hybrid multi-cloud. With Apigee, you can develop, secure, deploy, and monitor your APIs everywhere. You can easily deploy containerized applications that feature pre-built deployment templates and consolidated billing. This tool helps in moving your existing workload to the GKE container. Migrate for Anthos also supports workloads from VMware, Amazon EC2, or Azure VMs. You can aggregate metric logs and events from your infrastructure to get signals and to speed analysis. Google Cloud IoT Core is a fully managed service for securely connecting and managing IoT devices from a few to million. It lets you ingest data from connected devices and build rich applications that integrate with the other big data services of Google Cloud Platform. An edge device is a device that provides an entry point into enterprise or service provider core networks. Google Cloud Deployment Manager is a tool for infrastructure as code. It's an easy solution for deploying complex environments. It allows you to deploy, update, and tear down resources from Google Cloud using YAML, Jinja, and Python code templates. It helps to automate the deployment of all resources in G-Cloud in fast, easy, and repeatable ways for consistency and efficiency. Let's discuss the two major components, the configuration file and the template file. The configuration file is the structure of your deployment. A configuration file contains a top-level resources section, which in turn contains a list of resource entries that are used to configure the deployment. It must contain a resources section. Each resource must contain a name, a type, and a property section. A configuration file is written in the YAML syntax. A configuration file can contain templates, or a template can be abstracted into an individual building block. It is a separate file imported into a configuration. It can be generalized or specific. Deployment Manager templates allow you to break out a configuration into multiple pieces that you can reuse with different solution deployments. It can be written in Jinja or Python. It is a model for operation monitoring services for Google Cloud. It allows you to monitor, log, trace, and profile Google Cloud applications and services. Firebase is Google's fully managed platform with integrated, unified client libraries in various programming languages to develop and deploy mobile and web applications. Firebase is a platform as a service utilizing serverless technology to develop high-quality applications. It is an alternative to Google Cloud for users who want to build and deploy applications in highly opinionated frameworks. There are many services which Firebase provides. Some of the most useful ones are there on the screen in front of you. Let's discuss some widely used services a bit. Firebase is a great tool to implement notifications irrespective of the platform because it is fast, reliable, and scalable to handle your requests. Firebase provides authentication using email, password, and phone number using OTP. This service is majorly used to generate deep links that redirect user traffic to your landing page, website, or mobile applications. They also provide custom domain names, and if you have your domain name, the service can be integrated with that as well. As the name suggests, this service helps you in making predictions about your product decisions. Without having any machine learning experience, you can use this service easily in dividing the users in different fragments, and you can make decisions based on their behavior. Google Analytics is yet another service that helps in growing and managing your business. It can become helpful in tracking user demographics, behavior, purchasing patterns, revenue reports. The service provides visualization of all this information on just a single tap. The last service that we'll go through is remote configuration. It helps in remotely changing your application UI and content without publishing it again.